Hello, everyone. Nice to meet you. I'm Jeong-Yoon. I was Korean nuclear mechanical designer for over 30 years, a professional engineer, mechanical engineering register, both in Korea and in USA. I'm very pleased to have a meeting with you on the Zoom. Uh, Let me start the risk of APR1000 in Czech. KHMP received EU certification for APR1000 reactor early last year. Many design changes will be done to accommodate the EU requirements, but KHMP and related organizations does not have a big design change experience. I think that's a big problem in detailed design stage. I wonder how KHMP will be able to carry out these new big design changes within fixed construction period and the limited cost promised by themselves in the bid. The reason of low cost of Korean nuclear construction is mainly because copy design and repeated construction for several decades. Korean nuclear development policy has been focused on technical localization in design, production, and construction in Korea. Now, KHMP wants to export nuclear power plants because no more construction is possible in Korea now. Okay. Uh, OPR, optimized operating power reactor, OPR 1000 design is based on CE System 80, 1300 megawatt technical transferred to Korea by technical transfer contract. And then 12 units constructed in Korea repeatedly. APR 1400 design is based on ABBC System 80 Plus 1400 megawatt to the EPRI URD utility required document, and the APR 1400 design work is done by technical assistant contract between KHMP and ABBCE. APR 1000 is OPR 1000 plus APR 1400 plus EU requirement. So it requires big design changes. Therefore, there is no verified and proven design of APR 1000 exists up to now. This Korean nuclear industry has been organized for the purpose of self-reliance of technology in each functional companies. Nuclear construction work is normally done by EPC, procurement, construction by engineering, design. EPC led by engineering companies such as Westinghouse, ACL, Areva, etc. But KHMP is an utility company, and the role is project management without any basis of engineering background. Engineering documents produced by KEPCO ENC, but never been reviewed by any third party because most of them were produced repeatedly. Doosan orders to subcontractors and supplies all enterprise equipment, including turbine generator, using design document produced by KEPCO ENC. So KHMP's project management is bureaucratic procedures with less accountability rather than responsible technical judgment. Absolutely. no efficient for big design changes. Then, who is responsible for the schedule delay and cost rise? HMP, Korean government, otherwise Czech Republic. This is not a common construction project, huge international project. This is a one-decision chart of Korea for the project nuclear construction. All final decisions should be made by HMP. The role of engineering is sometimes just a reference in the final decision. HMP controls budget, schedule, and quality of equipment supply and construction with technical support from KEPCO ENC. Final decision will be made by KHMP anyway. Technical matter will not be a major concern in decision-making process in many times. KHMP intervenes in all fields and steps of nuclear supply. KHMP's hegemony, together with the corrupted politicians, is a big source of corruption in 2013 Korean nuclear scandal. KHMP's annual R&D investment of $350 million, by which it controls high level of nuclear elite group and security. It builds strong nuclear business cartel, academic, research, engineering. Korean nuclear scandal in 2013 has not been stopped because the system of corruption has been unchanged. Still now, KHMP staff re-employed after retirement to subcontractor companies. All of these can affect the safety and quality of nuclear power plants. Some examples posed by KHMP's purchasing programs. KHMP purchased and installed passive autocatalytic recombiner at all nuclear power plants in 2013. But it was pointed out the quality document forged. So KHMP did a power performance test again, but the test was interrupted at 8,000 seconds during the test because the flame rise. However, the performance test was accepted no problem by KHMP and Nuclear Safety Security Commission. So many citizens raised complaints and issues, but they dismissed the complaints and the power continuously installed at all nuclear power plants in Korea. After 11 years, when anonymous informant raised the problems, finally, KINS reported survey results that current power systems does not have sufficient hydrogen removal performance, but the flames are still acceptable, unbelievable. The flame can be minimized simply by changing catalyst manufacturing method. So many people doesn't understand KHMP and Nuclear Safety Security Commission's action for the safety. Another example is KHMP purchased containment filter vent system here and installed first at Walsong Nuclear Power Plant Unit 1 in 2012. During the installation, the piles penetrate the uh, uh, water leak protection sheet on the ground, but didn't recognize it for many years until leakage raised by unknown informant in 2020. So many citizens and social organizations asked the government to organize joint investigation team. KHMP, however, dug out the damaged underground leak protection sheets in advance. They removed them. So, finally, no punishment. However, it was also found that the contaminated water was overflowing from another resin storage tanker and flowing over into the sea, but no measures were still undertaken. How BMPP was successful? The answer, Arakan nuclear power plant, was successful. The answer is that FANR, uh, the regulatory body of UAE, hired ex-US NRC staffs and regulates all design and construction process without Korean nuclear safety assistance. So Korean regulatory body assistance, they do not depend on Korean regulation. Okay, next example is man-machine interface system developed for localization in 2010 and installed first at APR1000 Shinhanul Unit 1 and 2. Construction delay at least 5 years due to technical problems and final start operation in 2022 and 2024 for Unit 2. However, Shinhanul Unit 1 shut down for MMIS error in January 2024 this year. I'm not sure this system also installed and checked project. And the pilot operated safely fail. Engineering accepted CBIM, CCI valves after technical review in the bid process for Barak nuclear power plants supply. But KHMP wants a sample product to be in the vendor list. Sample finally won the bid and they installed both in Shinhanul Unit 1 and 2 and Baraka nuclear power plant. All installed POSRBs leaked during test. So, NF UAE nuclear power plant utility, NF, requested replace them all in Baraka. KHMP wanted to use them as is by repair. It delayed commercial operation by 4 years. And also, additional example is construction. Concrete cavity was found inside the reactor within all Korean nuclear power plants. The largest one was 157 centimeter depth in the 167 centimeter wall thickness. The concrete was not sufficiently compacted during construction. This might be driven by HMP to comply with construction deadline. The cavity was also found in Parakan nuclear power plant as well. Now, it's a new design, big design changes. Cooling towers, new big design changes will be challenging to HMP in Czech nuclear construction. HMP does not have design of large cooling towers, so no experience in design, construction, and operation of cooling towers. Therefore, it is expected a lot of try and error during construction process of APR1000 construction. Additional new big design change is double containment wall. Double containment wall. When designing a double containment wall, the spatial arrangement must be updated. Huge design changes must be involved. There are thousands of penetrations, passing pipes, and attachments on the rigged building wall. It makes a lot of design interfaces among lots of related organizations. Many trial and errors are expected during project undergoing as well. Additional one is the big design change co-catcher. Korea does not have completed design and construction experience for co-catchers. Additionally, third-party review system to minimize errors does not exist in Korean design system. The performance of packs must be verified by precise experiments on an appropriate scale before construction and should be inspected and confirmed its performance by independently. APR 1000, APR 1000 reactor vessels supported by long column mounted on the concrete near bottom head shell of reactor vessel. It should be verified with the vessel support column when very hot corium could cause oxide, this concrete weaken and the loss of support function. I worry about. Westinghouse and EDF has been experienced difficulties already in design incorporating new engineering, advanced safety features, but Korean doesn't have. Korean strong points are present schedule, but these are not verified in APAR 1000 because incorporating new big designs for the safety. Finally, Korea always performed the design with the technical assistance of Westinghouse. But at this moment, it may be different situation in China. Westinghouse sued Korea, KECO, and KHMP over intellectual property issue. On October 2022, Westinghouse filed a lawsuit against the KECO KHMP in the U.S. District Court of Columbia for violation of U.S. federal law Part 810, which prohibits the transfer of nuclear technology to third countries without U.S. permission. In the mutual technical support agreement signed in around 2010 between Westinghouse and KECO KHMP to obtain APR 1400 design certification from US NRC. Korea recognized and specified in the written agreement that Korean reactor design is based on Westinghouse's own license. Since it was dismissed on the judgment that it is not for company to file lawsuit, but for US DOE. So it is understood that arbitration is currently undergoing, but the specific details not open yet. Part 810 describes all transfer of US technology shall be approved by US government, DOE. It defines the details of technology to be ruled under the law, Part 810, such as reactor vessel and the attachment composing fresh boundary and the control of reactivity, etc. If US permits KHNP export APR1000 to Czech, then Czech may not be able to export its nuclear technology transferred from KHNP to Europe without permission by US government as well. All permission requests written form to US government shall be made by Westinghouse only. CEO KHNP, Mr. Huang, and Minister of MOTI, Mr. Ang, visited the United States before KHNP submitted the bid to the Czech Republic. When submitting a bid to Czech at the end of April, the CEO of KHNP, Mr. Huang, and Korean Minister, Mr. An, visited the Czech Republic for on the table-close meeting. It is believed that a fairly close agreement are undergoing between governments for upcoming nuclear project. Project deficit may be expected because it's just too big, too long, and too much risky project and low possibility of successful construction because of many uncertainties. Korea may use Czech project for the opportunity of upgrading APR1000 design for Europe project upcoming. But the problem is how many nuclear projects possible in Europe. It's my presentation. Okay, thank you. Any question?
So what do you think about this self-presentation of KHNP, that they say, they claim that they can do the project on time and on the budgeted price? What do you think about that?
It's absolutely difficult, I think, because new big design, there are new big designs ahead of them. So before final construction finishment, nobody expected the big design changes. I made the examples. These are all first experience for them to perform design, construction, and manufacturing. It impact a lot of design interfaces into existing design. So huge design changes must be done to finish. So I say APR 1000 design has not been proved yet.
Now we have still some space for more questions.
Hello.
My question is, we have been working in the Baraka power plant in 2018. We were able to see everything, including the interior of the reactor, and to talk to the staff. The Baraka was on time and on budget completed. The reason why the operation was delayed was that the Koreans, that they are really passionate about the formal education, they didn't understand that this is not so in the Saudi Arabia, and they were unable to train enough staff so that they were able to put this power plant in operation in 2019. So could you could you tell us where did you find these 4 years of delay? Because there was no such a delay. Thank you.
Okay. I think you, in my understand, you are telling me there are no project delay in Baraka nuclear power plants, right? Is it correct? I think that they delayed at least 4 years in Baraka nuclear power plant construction. Because they contracted 2009. Okay, bid completed 2009, and they started the construction 2010 to 2011, and this is 2022. So it takes more than 12 years.
Are there any more questions, or would you like to follow up on that? Looks like this gentleman has... Okay, what is the question?
Yes.
I don't think I would disagree. You start the construction when you were pouring the concrete on the foundation slab. Okay, my question is, why you are saying this? Because this is not so, I'm afraid.
Sorry, in my understand, why the cavity happened in the concrete construction, right? So there is some construction method related problems. It's a copy design from C System 80, hollow body USA design. They didn't revise the design. Originally prepared for hollow body nuclear power plant, so copy design. So the pouring, concrete pouring should be more hardened and be careful. But they deadline, concrete construction deadline is more important for them. The steel liner at the inside of the containment building, there is a steel liner, so it hides the cavity. So everybody didn't know after construction the cavity existence.
Tak, je tady ještě nějaký jeden poslední dotaz.
Do we have any last question, please?
V tom případě,
No.
pokud dotaz není, tak vám moc děkujeme,
Thank you very
že
much
jste byl součástí
for
tady
being a part of our conference. Sorry for any technical issues, and have a good day.
Okay, please let me have questions, written questions through Mr. Polonecki. If you can send me written questions, I will respond my best, okay?
Tak, Slyšeli jsme, já tady
Okay.
zakončím tady spojení s naším korejským řečníkem. Pokud máte nějaké další dotazy,
So
můžete se na něj
let's
určitě obrátit
shut down the connection. If you have any questions to the speaker, he will be happy to reply by email. And the next speaker will be Tom Clements, the Savannah Riverside Watch director, who will talk about the APR1000 of the Westinghouse reactors in the US.